All right, back with our last question from 25G, the Poisson distribution. This one's a little bit challenging. Great Part D question or Part C non-routine. Nothing overly complicated, just makes you think a little bit. We'll see how we go with this one. So, first one, we've got a random variable u, which has a Poisson distribution with a mean of x. Y is the probability that u takes one of the values 0, 1, or 2. Fine. An expression for y as a function of x. So what is the probability that u equals 0, 1, or 2? So that's equal to y. So y is equal to probability that u equals 0 plus probability that u equals 1 plus the probability that u equals 2, because it could be any of those values, couldn't it, to satisfy y. So how do we go ahead and do these? Well, we need to rely on our definition. So it is m to the power of x, e to the negative m over x factorial. That's our general rule. Now in this case we've got to do it for x equaling 0, so we can go ahead and make this look a little bit nicer. Didn't mean to rub out everything there. So m to the power of 0 over 0 factorial. If you're not sure 0 factorial is equal to 1, you can use your calculator to confirm that. Here I've got m to the power of 1, e to the negative m over 1 factorial, which will also be equal to 1, plus I have m squared, e to the negative m over 2 factorial. So if we want to make that look a little bit nicer, e to the negative m is a common factor. Let's bring that out. And here I've got m to the naught is just 1 plus m squared divided by 2. And there's an expression for y as a function of x. Happy with that. Sketch the graph of y between 0 and 3. Okay, we can do that. We've got a calculator. Be expected to use your calculator for this one, so there's nothing wrong with doing that. Delete it. Yes, I want to delete it. And here I have shift e to the power of negative x. Might want to put brackets around that. It'd probably cope fine, but I like to err on the side of putting the brackets in rather than figuring out later that I needed them. Now, what's the rest of our expression? I've covered it up there. We've got 1 plus x squared. Should probably have brackets around that, just to make sure I get it right. X squared divided by 2, and then close the larger bracket. Our brackets all match up. That looks pretty good. And we want it only for the domain 0 to 3, so let's actually put that in. Or maybe I'll just make that negative 0.5 or something, just so I can see a little bit. And up to 3 point. No, actually only up to 3, because otherwise I'll confuse myself. The y min or max, we're not sure yet. Let's just leave it like that and see what it looks like. Pretty good, it's getting smaller. We can probably change that viewing window then, can't we? You could have figured that out before, but that's okay. Doesn't want to scroll down. Let's scroll down now. So obviously we're greater than 0, and the maximum, well, we didn't really need to go even as high as 2, so that will more than cover it. Exit, draw, beautiful, look at that. That's not too hard to draw then, is it? So my sketch, oh, the whole lot's disappeared. I'm going to pause and get that back. Hang on a second. Alright, well it's back. It didn't come back as easily as I thought it would. I had to go and find it again and stick it in, but it's there. This graph looks something like that. Is that a good rough estimate of what I had there? Well, probably it went on for a little bit long, but you got the right idea. What do we do when we sketch a graph? We label our axes and label the equation. So let's go ahead and do that. That's my y-axis. This is my x-axis. They continue in all directions as straight lines. And here we have the function. So you can either label, just say, I'm just going to, for convenience, just do it like that. You, of course, in your exam will have much more convenient implements to write with and have no trouble doing it. Okay, there it is. Use sketch the graph, done. Use calculus to show that as the mean increases, the probability of u being less than or equal to 2 decreases. So the probability u is less than or equal to 2 is just y. So we show that y decreases as the mean increases. Well, oh, I've got the question in there twice. Obviously, it's stuck it back in now. Let's see if I delete that, whether it shows up. There it is. Crazy OneNote. All right, there it is again. So use calculus to show as the mean increases, the probability that u is less than or equal to 2 decreases. We can see that it looks that way if I could draw horizontal lines horizontally and then slightly less than horizontal lines, slightly less than horizontal rather than slightly inclined as I have there. You'd be able to see it. You can certainly see it on the calculator, although it's horizontal for that first bit from what we can see. So how do I show that it's decreasing the whole time? And it says to use calculus. Well, they've been nice. They've given us a clue there, haven't they? If function's decreasing, what do we know? Derivative's less than 0. So let's just find dy dx. Okay, well this is a product rule because I've got a product here. Although, yep, that's e to the negative x and then 1 plus x. So product rule. So derivative of the first one, so it's negative e to the negative m. Leave the second one alone. 1 plus m squared over 2. Plus, leave the first one alone. E to the negative m. And multiply by the derivative of the second one. Derivative of 1 is 0. Derivative. That's better, isn't it? Derivative of m is 1. And derivative of m squared over 2. Multiply by 2 and the 2's are going to cancel. I'm just going to be left with 1 plus m. You can see when I simplify this here, I've got negative e to the m and positive e to the m. They cancel. Negative e to the m times m. Positive e to the m times m. They're going to cancel. I'm just going to be left with negative e to the negative m multiplied by m squared over 2. What do we know about that? This is always less than or equal to 0 for m greater than 0. And in fact, it's always less than 0 for m greater than 0. I don't even need the equal. So it could equal 0 if m was 0, but we know that our mean value can't be 0 for a Poisson variable. So there we have it. This thing here, it's always negative, correct? And something squared divided by 2 is always positive. So I've got a negative because it's negative e to the power of something multiplied by a positive. Answer still negative, which is less than 0 for all m greater than 0. Therefore, y decreases as m increases. And you've done it. You've got out the tricky question. All right, that's it for Poisson. Hope you enjoyed them and that they helped a little bit. See you guys.